Good afternoon, everybody. Um, I will talk about some techniques for improving basically the startup JVM. My name is Ionut Balosin. I work basically in Vienna, in Austria, for Raiffeisen Bank International. My official role is a software architect, but besides this, I do a lot of extra stuff. For example, I go to conferences, I write articles, I also lead or conduct trainings, workshops. So if you are interested in one of these topics from this slide, you can get in touch with me. But this is basically the only commercial part I have. Nevertheless, the main interest for today is the agenda, what I will talk about, what I'm going to present you. My presentation is structured in three main areas, but we will start with just a briefing about cases when JVM startup matters, because probably you would think this is not always needed, or even if you improve the startup performance, some of your clients might not even notice. So I will tell you which kind of applications when this is important. And then basically the majority of my talk is split in three main areas. I will share with you three options or strategies to improve the startup time performance by using three different, for example, JVMs, HotSpot, OpenJ9, and Graal VM-ative-image. And for each, I'll have also some hands-on demonstrations so we can actually get a grasp what it is about. Okay, but let's start now with the introduction part, when the startup really matters, for what kind of applications. In my experience, or based on my experience, I would say not always, but when it matters, in essence, is basically for function as a service applications. Most of us are using cloud today. And for example, you can create what is so-called serverless approach in your application. You use, for example, the CDK from the provider, and you create your package, and then that's it. Basically, the cloud provider is able to run it. And the problem is, especially my experience comes with AWS, these lambdas have a long startup time. So basically, if you wait something from the lambda, and this is on a critical path, you might encounter a delay. So this is one category of applications for serverless applications, in particular for function as a service, but also for CLI, for command line applications. So if you code something and if you create a command line application, of course you want to start as fast as possible. The benefits are more obvious if we talked about cloud. So mainly we deploy to cloud today, or majority of us deploy to cloud. It's about cost savings. And why I'm talking about serverless and function as a service, because I always found in practice a good mix, integrated, for example, function as a service in your architecture where it makes sense. So this is basically cost savings, but also you can have, for example, a quick feedback during deployment cycles if your JVM starts faster. All in all, I'll focus on the first time to first response. In so-called cold scenarios. What is this cold scenario? There are basically three areas: cold start, warm startup, and hot startup. Basically, cold startup refers to the fact that you start the application from scratch and basically it's ready to fulfill your first request. Hot startup is the opposite, and of course, in this cold startup, you have to wait until, for example, the bytecode is loaded and so on and so on. And the hot startup, you have the application in a steady state, so which means basically it reaches a state where, for example, the methods are compiled, you can run, and of course the latency it's minimum. And you have so-called in the middle what is warm startup. It's basically the phase where you prepare, you basically trigger, for example, some internal compilation, some class loading activities in order to reach a steady state. But in essence, I'll refer today about cold startup. So basically the startup time from the moment I run the JVM until it fulfills the first request. And also during the last part, I will also show you, for example, this hot startup time from the Graal VM perspective. If you think, or if you wonder what alternatives we have today in our JVM ecosystem, there are quite few. For example, even today in the conference, I saw this OpenJDK crack presentation, which is another alternative where you can benefit of for example, snapshotting the current JVM and basically storing it later on, relying on the fact that, of course, restoring it's much more faster because you preserve a lot of information. For example, the code is compiled, so you can reuse it in a subsequent run. There is also OpenJDK project Leiden, which is in a very incipient phase. The JVM from Alibaba has what they call JWarp, where you can, for example, if you use that JVM, you can leverage on JWarp to speed up and so on and so on. Nevertheless, today my focus is on the top three. And I will take one by one. I will explain. I will demo each of them, and then you can make some conclusions. Okay, so let's start with the HotSpot JVM, which is probably the most spread JVM in our ecosystem. And from the HotSpot perspective, I will talk about CDS, what is so-called CDS, but it comes in different flavors. And I will explain each of them also from a historical standpoint to understand what are the high level, at least, differences and what you can benefit out of it. So this is, as mentioned, a hotspot. So in hotspot, since I think Sun 1.5, there was this so-called class data sharing. What it is class data sharing? In essence, basically, you know that after you start a JVM application, you run your main program, the bytecode it's loaded, it's verified, there are a lot of allocations and so on and so on. This is so-called, and all of this takes time. And for example, the improvement is what if I basically just snapshot the bytecode which was loaded in that moment in memory. I just snapshot in an archive. So the next time I just map the archive basically. So I implicitly, it's like for example, I was loading all the classes and bytecode, but it's much faster. So basically, the CDS in a nutshell is about caching pre-processed metadata on disk as it came. And this feature is basically since a while. As of JDK 18, I had a look. It contains about 1,300 core library classes. This only contains core library classes. This doesn't contain any, for example, application class path class, or if you have some custom class loaders. This is just core classes, for example, Java IO, Java Neo, and so on and so on. Basically, since JDK 12, this archive it's created in the moment that you basically install the JDK. And here are the locations you can also inspect in your box. For example, if you have a Linux or a Windows machine, they are slightly different. But nevertheless, the archive itself, CDS archive, is inside this file, classes.jsa. And as as already mentioned, it contains only system or core classes, the classes that are most used across basically these Java applications. And this is the entire rationale around it. The problem was that, of course, it's quite limited. If I have to tell you how much speed, if you disable CDS, probably you even notice it. It's 100 milliseconds, 200 milliseconds. It really depends, but it's in this range of 1-200 of milliseconds. And as you can think of, yeah, well, it's probably not a lot. And what happened starting JDK 10, AppCDS emerged, and with AppCDS, basically the concept is extended actually to application class loader and custom class loaders. And this is already a benefit, because now you can include in this archive more and more basically classes. So in a nutshell, it will improve even further the startup time. This is also called static archive. This is for historical reasons, but in a nutshell, it just extends the concept to other classes. I mentioned about this mechanism of, for example, you load the classes, and then at some point you basically cache all of them, store all of them, dump on disk file, and then in a subsequent JVM runs, you just map that archive, and it's much faster. I want to tell you that this archive, it's not like the format is totally different. It's not like you create you compile your Java class and you have the bytecode. And in essence, what I want to emphasize, the idea that the footprint, it's larger. On average, could be like 3 to 5 times larger than a normal class, a normal class footprint. And here I made a short test, basically for let's say 3,959 classes. The footprint was 2187 around megabytes. So in a nutshell, well, this might not be a problem because the storage is cheap. Nevertheless, just warm you a bit. So if you have like unnecessary classes, maybe don't store them in this archive. One more aspect about CDS archive. CDS archive includes already the CDS classes, because CDS refers to the system core classes. When you create app CDS, it also includes the CDS archive. So basically, it's just one archive containing both system core classes, plus, for example, the classes that you have from the application class path, loaded by application class loader, or, for example, custom class loaders. And then what was maybe an inconvenience with this app CDS, it had basically 3 steps to create it. First step is to create the class list. The second step, you run the JVM with the class list to create the so-called the app CDS archive. And then on the third step, you basically run with the app CDS and see the improvements. I will show you in the demo. And then starting JDK 13, actually, dynamic CDS came into place. And I think from this moment, at least from my perspective, it's starting to be a bit more easier. And I also saw some improvements, especially in the latest JDK versions. What means dynamic CDS? Well, it's dynamic, again, due to historical reasons, because the initial one, app CDS, it's called static, and this is dynamic. It's dynamic mainly because the fact that it's created at the end of the JVM. and only in the case when the JVM successfully or gracefully shuts down. If you kill the JVM process, this archive is not created, and basically you need 2 steps to create the dynamic archive. In comparison with the previous one, there you need, for example, 3 steps. And these 2 steps are: first, you start the JVM, you send the flag to the JVM telling I want to create the dynamic CDS at the end, and then once you basically send Control-C signal to the JVM, you have it created locally, and then in the next run, you can reuse it. This is basically an advantage, of course, because it's easier to be created, but also it's from architectural standpoint, it's slightly different in the sense that it uses a layering approach. What means basically when you create a dynamic CDS, it doesn't contain anymore the CDS archive. In the app CDS, the previous one, this it's just one archive. If you have a dynamic CDS, this is a standalone JCA file, which basically points to another one, which could be the basic CDS archive. But I have all of this illustrated here. Maybe I move this. How it is when you it's a layering approach, as I mentioned, and on the top layer you have the dynamic CDS, and the dynamic CDS, this is one file, basically a JCA file, and then this has references to a base layer, and inside this base layer could be by default is the CDS archive, the one which comes in prepackaged with the JDK when you once you install the JDK on your local machine. This is the default behavior, or you can even make a bit of more exotic customizations. For example, you can create an app CDS in the base layer archive, and dynamic CDS can refer to it. Personally, I never seen this situation. For example, when a dynamic archive points to an app CDS, but it's possible. You can also, for example, if you have 2 archives, like a static archives and a dynamic archive, like for example, you have an app CDS archive and a dynamic CDS archive, you can chain them, and once you run the JVM, you can specify both of them. So you can play with this. As mentioned, I didn't do it in practice. This kind of flexibility, I used only dynamic CDS archive as a top layer archive, and on the base layer archive, it was just the default one, the CDS archive. I didn't use CDS, dynamic CDS on top on the app CDS. This is basically about dynamic CDS. I will show you how it works in practice. And here, what I created on this slide, just some, for example, enhancements that I will consider worthy to be mentioned. Of course, there are a lot of such either enhancements, either bug fixes across the entire release versions. For example, starting with Sun 1.5, as I mentioned, when the CDS was introduced, then noticeable differences I saw, for example, in after 16, because what happened, as you can see here in 15 and 16, CDS archive, as it was released initially in 12, didn't include dynamic dynamically generated classes, which means basically if you have a lot of lambdas, and we have, because we do a lot of framework dependency and so on, so we have a lot of lambdas. These are at the runtime when the JVM starts, these are generated classes, and these classes were not not included previously in the CDS archive. But then starting 16, the Lambda support, it's there. So you can actually use either dynamic, either CDS, you have it included. And this was basically, in my opinion, you can see the difference if you run with 13 or, for example, 16, but probably you don't run at the moment with none of these versions, just for historical reasons. And then recently, what is basically another improvement I will show you, and this was a limitation at some point. If you created one CDS archive with, for example, JDK 17, or no, let's stay 13, and if you upgrade the JDK version, it didn't work. So basically, you had to regenerate the CDS archive always. So you had to do the manual step again. Starting 18, this is fixed, so this is automatically regenerated. All in all, that's mainly all. So in a nutshell, use the latest JVM because it's better. You have more and more enhancements, so you can see more and more noticeable differences. In terms of structure, this is the basic structure of such an archive. I wouldn't focus too much on the upper part because it touches a bit of JVM internals. If you are interested into this, you can read this. I have the slides anyway public. I will also send you the link. But what is important basically to be noticed, and you might face this in your tests. When you try to create the CDS archive, because it's in essence it's a file on the disk. This is mapped at the fixed address, and this is hard coded basically in the JDK sources. And of course, if you don't change this, and then when you try to map it next time when you run it, basically you might have problems because what is so-called ASLR might prevent you basically pointing to the same address, for example, always. It's basically a security patch in kernel. And from this perspective, so in order to be a bit more flexible, to not map always to this fixed address, there is a flag which is called share-based address. You can specify another hard-coded address, or you can say 0 and this map to whatever OS selects at that moment. So this you might basically face during your test. I sometimes disable ASLR. Maybe it's not always a good, but only in tests. Maybe it's not always a good idea. Nevertheless, be careful because you might think, okay, everything was fine, but then if you, for example, enable the CDS logging, you might notice, oops, it was not mapped. And the only way to see this is just to enable the CDS logging. And that's more or less it. Anyway, if you enable the CDS, just basic logging, as I mentioned, this is the flag is X log CDS, colon CDS. And this tells you what happens. And if there are some problems, of course, the JVM is not impacted at all. The JVM still runs. What you can get worse is just to not be able to use, for example, either the dynamic CDS or the app CDS. This could happen, but usually just to make sure, I do this after I do a proper setup and I create the archive. First run, I test with this Xlog CDS. And all in all, that's maybe about the first part. Let's do now a demo to see how it works in practice, right? Because I told you quite a bunch of information, but let's see how it works in practice. And for this practice, by the way, everything it's public. For this practice, actually, I use this GitHub repository that I've created, so you can also access it. And here I'm going to use the first part, which is app dynamic CDS. Here I also add instruction. It's basically a guideline how to do it. I read instructions also for AppCDS, but I will skip AppCDS. I will jump directly to dynamic CDS. And in the dynamic CDS part, of course, I need an application. And for this application, I choose Spring Pet Clinic. It doesn't really matter what you choose. You can do with whatever framework, whatever application. You can just use your own application. You can try it. It doesn't matter. But I just need some sort of application. So I thought Spring Pet Clinic, it's quite well known. And then let's see, for example, let's first build, package the application. So I'm inside this Spring Pet Cleaning. And first of all, let's select the JDK. Maybe I'll take 18. I didn't yet install 19, to be honest. I play with some release candidate, but I thought, okay, let's don't do this demo with a release candidate. So that's why I'm still using the last one, which is basically provided. Nevertheless, today it will be 19 released. So, but I don't think there will be much difference. So now I'm basically package the application um, with this JDK 18. And then what else I have to do is the first step is, as mentioned already, is to create to launch the JVM. And maybe I'll zoom in a bit. With this flag archive classes at exit. And what this does, basically, you start the application, and on the successful or graceful shutdown, it creates this application, dynamic cds.jca, in the local path. And okay, this is packaged, and now it's just a normal execution of this jar. Usually the server port 88 is not necessary, but I'll do it because later on I will start multiple JVMs. So that's why, just for consistency, I use other ports, not only 8080. So now I'm starting this Spring Pet Clinic application. And what is the catch here? If you play and if you want to generate this type of archives, don't just start the application and stop it. Why? Because, as mentioned, if it is created at the last moment when you shut down the application, and if you don't browse or hit all your endpoints in your application, it might be the case that, for example, you didn't load it all the classes, because classes are anyway lazily loaded. So that's why what I'll do to make sure that my archive is actually comprehensive enough, I'll try to browse, for example, the application endpoints. And here, what I can do, it's basically, let's try to edit the owner, right? So I just edit the owner. I maybe add a new pet. This is just dummy things that I'm doing now to trigger more and more endpoints. Maybe I'll add another visit for this pet. And why not? Let's add an owner. Let's call it Martin Musterman, Wonderland, Wien, and I don't know, my telephone number. Let's put it like, it's not my telephone number, and so on and so forth. Okay, so basically now at least I have the at least I try to call more and more endpoints from the application, relying on the fact that I have more and more classes loaded. And now I'm just stopping it. And as you can see, there are still some limitations here. For example, some old classes, I mean, not all the classes, even if they are loaded, they couldn't be included. There are still some limitations due to historical reasons. And in this case, it's due to the bytecode verifier. But nevertheless, you have something. And then if you search inside your folder, here, this is my current one, and dynamic CDS. This is what I did, and this is the timestamp. So dynamic CDS was created, and this is the first step. So basically, the was to just create it, and then If you want to start it again, that's fine. So if you want to start again, you have to specify this time shared archive file, and then you start it again, and maybe we got something. But I will do some tests, proper tests. So yeah, well, I don't know that yet. Let's do some tests now. Let's create, for example, sorry for this. Let's create, for example, a test scenario where I compare this. Let's kill all my instances to compare the basic time response time with the one where I use this dynamic CDS archive. And what I'll do, I'll create, or run a command. This is nothing special. What is probably something noticeable here is I'm using a shell script to measure from the moment when I start the JVM until the moment I got the first successful response, because I don't want to rely on any type of logging saying application started. I just want basically to make sure the application was starting, and this is what I'm doing. I'll just measure the time until I got the first 200 response. And this shell script, it's very simple. It just uses curl and uses, for example, an endpoint, which is this owner's find endpoint, which is provided by the application, and basically sleeps very, very tiny sleep, and then tries again. And now let's see. So this is the default case where I don't use the dynamic CDS archive on the class path. So it's the normal run. Let's see. So 9 milliseconds. And if I do it, let's do another test, maybe with this on port 8081, the same. Yeah, it's one dot something. Okay, let's now move to the case where I'm using dynamic CDS archive. So the archive that I created, this dynamic -cda.jca, and I'm launching this on port 8082. Let's see in comparison with the other two if I have some speed up improvement or not. Maybe, I hope yes. So it's decreasing from 987. And then let's try one more time. Anyway, my machine is not really a proper one now for test, because I'm using Zoom, so it also consumes memory and so on. But I think it's okay. You'll get a grasp about this. All in all, so with CDS, with dynamic CDS, this is basically, these are my tests where I didn't have anything on the machine, just the JVM run. And as you can see, that the default timing was around 7 seconds, and with dynamic CDS Pro in a lot, or on average, was -1 second. Yeah, so if this is enough, maybe no. In most of the cases, it's just 1 second in this setup. In practice, because this is a hello world, I got up to 20%, 20% based on my experience. Startup reduces up to 20% with dynamic CDS. And this is basically the summary around it. It might bring some startup improvements, probably not enough. If you are keen on this to reduce it even further, I will show you how to do that. Nevertheless, if you play with this dynamic CDS, you should try to dump the archive after a broader usage of the application. What I think it's important to mention are the constraints about this, or the things to be aware, because you might face them in your daily life. Important point is, if you create your application, if you create your CDS archive with one class path, for example, you create it during the tests while the tests are running, and then you run it on another system, it doesn't work. The thing is, you should keep the same class path the moment when you create the CDS archive from the moment when you run it. Or the other way is, or the second approach is to the class path that you use when you create it should be just a prefix or the class path from the moment when you run it. So if you basically, in a nutshell, it means if you create the CDS archive with one jar, and then you just remove that one, is not in the class path anymore, it's disabled. That's why it's a problem, basically, because you cannot create it during the tests, right? So you have to created in a normal, in a proper environment, dump it, and then start it again. The second maybe caveat around this is this compatibility across different operating systems. So if you're created on Linux, of course, you cannot port it on Windows or Mac OS. This is not reusable. And third one, which is important, but this was fixed as already mentioned in starting with JDK 18. If you create it for one JDK version, even if you keep the same OS, but you upgrade the JDK, it won't work. So you because this is not regenerated, this happens since JDK 18. So be very careful. These are really corner cases, but you might be very annoyed at some point about this. But I think if you have this in mind, it's much easier. And then so this is about the hotspot. What happens inside another JVM? This is a totally different JVM implementation. A former IBM one, now it's called Eclipse OpenJ9. It's open sourced, and they have what they call shared class cache, SCC. The idea is basically the same. You run the JVM, and then you try to put in the archive some reusable pre-processed metadata, or for example, some allocated strings from the string table, for example. But the main difference with the one from OpenJ9 is that inside the archive, it's not only uh, um, bytecode or pre-processed metadata, but it's also code, compiled code, which was basically generated during the runtime. But for the next execution, because it's there, it's seen as AOT. So it's not an AOT like a Graal native image has, but it's AOT because it's there, it's dynamically compiled, and you can reuse it later on. And this is why it's so called AOT. But it's just cached just in time code, a compiled code. There are two things actually here. If you want to use this for in regards to custom class loaders, the first one is the sharing support. It's not included unless your class loader extends this one, or if it is not possible, there is an helper API basically where you can play with it, and you can, for example, make your custom classes loaded by that class. Make your own custom class loader, which doesn't include this URL class loader, be part of the SCC archive. So these are the two points. Nevertheless, I think in practice it's much more easier based on my experience to create the archive with this OpenJ9. Also, the rationale, how it works internally. So the classes are in J9, they are split in two parts: the ROM part, which is so-called immutable part, and the RAM part, which is so-called mutable part, and so on. And only the ROM class, it's basically included in the SCC structure and shared inside across multiple JVMs. What is inside this ROM class, or what it is about, basically pointer to interfaces or inner classes, and these are shared. But for example, the virtual table or the constant pool itself, this is not. This is part of the RAM class. besides these ROM classes, of course, they store additional metadata, for example, profile data for the compiler to make better optimizations and so on and so on. Okay, let's see how this works in OpenJ9. And for this, I'll basically go back to my repository and I will jump to the next tutorial, which is this SCC in OpenJ9. From here, what I will do, I will just I'm still in this path. I will just basically select now the OpenJ9. So for this S18, so it's selected as you see, IBM Scenario Runtime. And now this step is not necessary, so you can just avoid it or omit it to recompile it. Yeah, it's not necessary at all. I'm just doing for the consistency perspective. And meanwhile, I will explain to you how this looks like. So if you want to create the archive with OpenJ9, of course, there is a different set of flags. So the most important one is this Xshare classes. You specify the name and the directory where you want the archive. These two refer to a soft limit and the hard limit that you can specify. By default, I think that the hard limit is 2 gig. So I set implicitly around 200 megabytes. And here I'm tricking a bit with this quick start. I can also omit it if you want. This is tailor-made for the startup improvement, which means in a nutshell, it tells the just-in-time compiler, please try to squeeze as much the performance as you want for the startup time. Nevertheless, it's not recommended for long-running applications because this the compiler starts with a subset of optimizations, but they're very very specific for the startup. Okay, so as mentioned, the important one is the first one, and all the others are just nice additions. And now I'm launching the same application, and what I'm okay, I put already in use because I didn't kill all the previous instances. So here it is. Now I'm launching it again on port 8080. And let's see, for example, I'm trying to do the same things. I'll try to browse through the owners. I'm trying to edit an owner just again to trigger more and more classes to be loaded. Then I add a new path, for example, 10/10/2022. And then I add a visit, for example, here, and I think I just need to add a new owner. Again, the same Martin Musterman, made it sound too, it doesn't matter. And one telephone number. Okay, so basically that's more or less. I hope I triggered enough. And then if I just, okay, and can close it. And let's see, ls minus all. The archive is this one. By the way, the name is a bit confusing, but remember the SCC, which I basically specified here. So SCC. And as you can see, it was created right away. And now what I have to do is I want to measure basically the time, how much I get in terms of improvement if I trigger the same command line, but now I measure the time to first response. And let's see how we get. So the best one from the previous case, I think it was 6 seconds or something. And now it's slightly better with this one, like 5 seconds here, and probably it will be still around. Yeah, it takes more something. No, sorry. I messed it up. I changed just the port here and not from here. Sorry for this. So it was just hanging. Now it should be fine. Yes, so it's 6, 5. Again, this is not very representative because as mentioned, I have also the Zoom application, which is quite heavy. But in a nutshell, that the times were reduced 5, 6 in comparison with the previous one. On a stable environment, I would say I've got around 4 seconds. So it's even lower than the hotspot. But the question is, does this fulfill your needs or not? It basically depends. If you already use J9, maybe this is cheaper to just enable it because it's also easier to work with it. DR Hive, it's always automatically refreshed in terms of context. So for example, if you compile or load a new class, if it is not there, it's edit and so on and so on. So you just start it once. It's quite easy. But still, in terms of performance, if it doesn't fulfill your need, then what can I say? You can do other things, but in essence, I would go to native compilation. Especially, remember we talked initially about the serverless or function as a service applications, and if you really want to be as fast as possible, you have to go to and compile natively. And in this case, this is the option for Java, or the alternative approach for Java is to use GraalVM-ative-image. The compilation process from the sources till the end until you get the executable or the binaries, it's highly described here. Nevertheless, basically, it's a paper. There is a lot of research around GraalVM, so you can read through a lot of sources. The main idea how this compilation works is that, for example, during the build, the application is configured and it's initialized, and basically it tries to reaches all the possible paths that you can reach via the code. And this is basically a phase where all the entry points are discovered and reach until you reach a point, and from that point you cannot discover anymore. And it's compiled only what is discovered basically. And this is what is so-called closed-word optimization, because in this executable, it's included only the methods and the classes that were discovered during this build process. And now, if I have to basically do a demo with this, I will show you. I cannot use basically the previous Spring pet cleaning application. The problem is, or one of the constraints, if you go to native, you basically need native extensions from frameworks. So you cannot just go and port your application, especially if you have a lot of third-party dependencies and legacy stuff. I doubt that you can do it and you can compile it with native, because you'll get a lot of impediments. But if you start from scratch, and this is very, very simple, and in such a case, you can use, for example, the Spring project, but with native extensions as mentioned. And for this one, I'm using basically analogous example, which is pet clinic -jpa, which I can found here. So I changed the project. By the way, this is Spring native. It's not anymore Spring pet cleaning. And here I'm going inside this directory. Sorry, this directory. And from here, what I'm doing, I want to trigger the compilation. I have it already compiled. The reason for that is it takes probably 1, 2, 3 minutes. It really much depends. So I just want to be fast. So I have this binary already available. So now what I'm doing, basically, I'm just starting it, and you can see it's 124 milliseconds. And if I do a second test in here, basically, yeah, it's 690 milliseconds. So all in all, it's much faster. It's not even a comparison between these approaches. Of course, there are some caveats. You need to have extensions for this. Most of the modern frameworks have, but also the problem is in the transitive or third-party libraries. They also need to prepare for this AOT. There are also some limitations with Graal native image. You can find all of this in the reference manual. Here I posted a link. By the way, you have to fill in the version. Nevertheless, in a nutshell, if you use, for example, like additional configurations, like dynamic class loading reflections, this might not be, you have to explicitly instruct the build process to take also this into consideration, or some features might not be supported, like invoke dynamic and so on and so forth. So this comes all in all with, if you go into this direction, you have to be careful with this. But in my opinion, if you're really keen on startup for this short running processes, and you want to be very fast, I think native compilation it's the way to go. Also, OpenJDK Crack, I saw some demos. It's promising. But yeah, we will see how, in which direction it goes. But at the moment, it's also that option. It's amazing as well. All in all, that's it. Thank you so much for your attendance. And yes, if you have some questions now, I would be glad to answer. Yes, so I can share the slides. By the way, I will send you here the link. So I sent you here in the talks. Maybe I was a bit too lazy. Let's copy the link because in the talks I have all the links, copy link address, and these are the slides directly. So if you don't want to jump into my website, you just click on that PDF. Yeah. One more thing, if you play with this feature, at some point I wrote an article about this where I explain even in more details. You also have the link in the chat, actually. So that's why I sent you as a reference this additional link. Hopefully it will help you.
Thank you very much. So we need to end now. Okay, maybe one more question and then we finish.
Yeah. Do you think HotSpot will continue getting better and closer to Graal AOT? There are some trade-offs with AOT still. Yes, there are trade-offs to AOT still. I think the HotSpot continues to be closer as I see these initiatives, for example, where these are. This project Leiden, I think it's a promising one. It's in this direction that your question points to. The problem, I didn't see much, let's say, progress on it. I don't know. It's hard to tell, basically. Maybe I don't know. I mean, the intention is there. There are initiatives, but at the moment it's still it's not the same parity with the native image. Crack, it's still interesting, but of course there are also some at the moment limitation with also Crack. Maybe Crack, if you run on Linux, and if Crack reaches a production ready state, maybe this would be a very good alternative to the AOT. It's hard to tell. I mean, yeah.